Pretty much every geology class boils down to one lesson. On this planet, nothing lasts forever. Weather and tectonic plates mean rocks are constantly getting ground down, buried, or melted. But continental cratons are about as close as you can get to everlasting on this Earth. These are the ancient cores of continents, billions of years old, with massive roots that extend deep down into the mantle. They are one of the most stable things on this planet. That is, until they're not. See, some cratons seem to have lost their massive roots. Scientists have long puzzled over how exactly this happens. That is, until now. They just caught the North American craton in the midst of slowly dripping away into the mantle, and they have even found the culprit to blame for sucking the base of the continent away. Over the last few billion years, continents and supercontinents have come and gone, but the cratons at their cores have remained. You might be sitting on top of one right now, given that about 63% of the continental land today is on top of a craton. We actually aren't sure how cratons first formed, but we know it happened billions of years ago. Through some combination of plates colliding, subducting, and maybe even a massive plume of hot material coming up from the mantle, cratons built deep roots of rock. And like really deep. They're up to 350 kilometers thick. And these thick roots are a big part of why cratons are so stable. The roots insulate and protect them from things like mantle plumes that could melt or break them apart from below. While this is, of course, all far too deep for us to dig down and see for ourselves, we know all of this because scientists can use seismic waves to get an idea of what's going on down there. This is called seismic tomography. Earthquakes release waves from a single spot, which travel outward through the Earth. But the waves travel at different speeds through different types of rock. So by comparing the time it takes for them to reach detectors around the world, geophysicists can slowly piece together a picture of structures incredibly far below our feet. That is how we can see cratonic roots extending deep down into the mantle. But beneath one craton, the North China Craton, the picture is very different. This craton has lost its root. Remnants of volcanic eruptions that punched through the craton 470 million years ago look pretty typical. They include bits of rock that came from the mantle beneath a 200-kilometer thick cratonic root. But since then, that root has vanished. It's hard to picture the scale of a process that could destroy something so massive. There's no shortage of hypotheses attempting to explain it. So to find out for sure, scientists wanted to catch a cratonic root in the act of vanishing, and in a paper published in 2025, they did just that. A team of researchers took information from around 200 earthquakes detected by over 6,000 seismic stations and put together an incredibly clear picture of what's going on up to 1,000 kilometers beneath North America. This allowed the researchers to see a cross-section of the North American craton, revealing literal drips of it falling off its root and sinking down into the mantle. So the North American craton is slowly dripping away. Hopefully very slowly. I live here. But to figure out why, the researchers needed to look at what else is hiding down there. Thousands of kilometers below North America, far below those drips, they saw another tectonic plate. The seismic image included an ancient oceanic plate that once formed the seafloor of the Pacific Ocean. It's called the Farallon Plate, and 30 million years ago, it finished slipping beneath North America and sank deep down into the mantle. But when plates subduct, they don't actually melt back into the mantle right away. In fact, they can take their sweet time, up to hundreds of millions of years. So to figure out if the Farallon Plate is to blame for sucking bits of North America away, the researchers built a computer model to simulate the conditions down there. And sure enough, in the model, drips started to fall off of North America. And when they removed the Farallon Plate from the simulation, the drips disappeared. So we subducted this guy, and now it's getting us back. So here's what they think is happening. First of all, as the sinking plate heats up, it releases fluids, mostly water, that were trapped inside minerals. This weakens the craton above. The motion of the plate sinking stirs up the mantle and causes it to flow and circulate in a way that literally pulls the drips off of the bottom of the craton. Now, if you happen to be watching this video from North America, fear not. Losing the cratonic root beneath your feet doesn't mean the Earth is about to open open up and swallow you whole. But understanding cratonic roots is crucial for geologists to figure out the movement of tectonic plates, the formation of volcanoes, and the creation of valuable minerals. Ever since geologists first found out what cratons were in the 1960s, they have realized that they are a good place to look for gold and platinum and diamonds, like Minecraft or Lil Wayne's mouth. In fact, we get the vast majority of our gold and platinum and nearly all of our natural diamonds from cratons. Remember how the North China craton lost its root? It's one of the richest regions of gold in the world. Most of the gold mined in China comes from this area. And all that gold is around the same age as the time the cratonic root vanished. And that is not a coincidence. In the 80s and 90s, geologists thought this was because the lowest part of the craton just happened to have a ton of gold in it. But more recent studies say that's not quite right. Scientists think that as the root is removed, material from the root and mantle mix, and this causes a series of chemical reactions that eventually allow magma to carry gold up to the surface. It's always wild to me to think about how much gold is down there. Just so much. Completely out of reach. And it's so valuable here on Earth. You see a gold nugget, it like makes your life. But down there, it's just like bubbling around. Can't get it. Too much Earth. Now, this was all around 120 million years ago, so it might be a bit early to stake your claim for a gold mine in North America. And while cratons are some of the most stable things on Earth, seeing them dripping away like this means that old geology lesson is still very true. Nothing on this planet lasts forever. Least of all you. You're just over in a blink. The self is an illusion. How we doing? Everybody okay?